Israel, a nation smaller in size than the Hawaiian Islands, where 60% of its landmass is desert and water is a scarce luxury, has achieved a remarkable transformation, becoming the Silicon Valley of global agriculture. How does a country with a population of fewer than 10 million people hold the keys to food security for over 500 million people worldwide? Today, with you, we will uncover how Israel turned the tables, transforming natural challenges into intellectual solutions, making deserts profitable, and even prompting giants like the United States and China to come and learn how to secure future food supplies. There was a time when every Israeli child grew up memorizing one rule: turn off the tap while lathering. This practice became almost an instinct for self-preservation in a land where natural freshwater reserves account for less than 1% of its territory. Israel is not the hottest place in the Middle East, but it is one of the harshest, hot, arid, and chronically water-scarce year-round. Situated between the massive, scorching furnaces of the Sahara Desert and the Arabian Peninsula, the country suffers from brutal climatic contrasts. While the north still receives seasonal rainfall, the south sees its precipitation plummet to less than 25 millimeters annually, equivalent to just a 30-minute shower in a temperate climate. Furthermore, the water scarcity exists not only in the sky but also beneath the feet. Israel has virtually no internal rivers large enough to support agriculture. The only lifelines lie deep within the coastal, highland, and desert aquifers of the Negev. These are finite treasures, risking saltwater intrusion if overexploited. For this reason, Israel could not survive without creating its own solutions. Beginning in the 20th century, rather than praying for rain, the nation decided to turn scarcity into a strategic advantage by actively producing water through technologies unmatched anywhere else in the world. To replenish its water resources, Israel chose a remarkably sensible approach: desalination of Mediterranean seawater. With a long coastline, stable salinity, and minimal impact from natural disasters, this water allows mega-scale plants to operate around the clock, irrespective of the weather. The key lies in reverse osmosis technology. Seawater is pushed under extremely high pressure through ultra-thin semi-permeable membranes, allowing pure water molecules to pass through while trapping salts and impurities, producing water that meets domestic consumption standards. However, what truly sets this technology apart is not merely filtration, but its energy recovery systems. By using the residual pressure from the concentrated brine outflow to compress the incoming seawater, Israel has reduced energy consumption by up to 40%. Consequently, production costs have fallen to a record low of less than $1 per cubic meter, among the lowest globally. The result is astonishing. Approximately 80% of Israel's domestic water supply now comes from the sea, virtually eliminating dependence on natural rainfall. However, desalinated water is extremely expensive to produce and transport, so it is primarily reserved for domestic use. To sustain large-scale agriculture in the desert without depleting the national budget, Israel tapped into an often overlooked resource: urban wastewater. This solution has propelled Israel to global leadership. Up to 90% of its wastewater is reused, 3 times the rate of the United States. At large-scale treatment facilities, wastewater containing organic pollutants and microorganisms is fed into massive aeration tanks. Here, bacteria act as natural decomposers, consuming and breaking down harmful organic compounds, turning dark, contaminated streams into basic clean water. Next, pressurized filtration and centrifuge systems remove solid impurities and sludge from the flow entirely. This closed-loop process ensures not even the smallest debris escapes, preparing the water for its most critical purification stage, underground. The water is then directed to desert reservoirs for groundwater treatment. This is the most critical phase in the water reclamation chain. It slowly percolates through sandy layers, reaching depths of up to 100 meters, using the earth itself as a massive biological filter to thoroughly eliminate bacteria and any remaining contaminants. From this point, the reclaimed water achieves purity comparable to drinking water, supplying over 60% of agricultural land in the Negev desert at a cost of just 1/3 that of desalinated water. But water alone is not enough. For centuries, drawing water from wells was one of the most grueling tasks in Arab regions. Jewish settlers in the Negev and Jordan River Valley were forced to haul bucket after bucket from the earth, then carry heavy canisters on their shoulders to irrigate their fields. Water was scarce, the labor was intense, and much of this effort simply evaporated under the desert sun. Today, more than 90% of Israel's cultivated land has been transformed thanks to drip irrigation technology. Although Israel did not invent this principle, it became the first country to commercialize it and develop it into a fully integrated, large-scale system that operates reliably in both open fields and enclosed greenhouses. After passing through filtration units, water is fed into main pipelines and then distributed through smaller lateral lines that run parallel alongside crop rows. Along each line, drippers are spaced 40 to 60 centimeters apart, precisely where root activity is strongest. This ensures water is not wasted, but delivered exactly where plants truly need it. Unlike surface irrigation or sprinkler systems, drip irrigation fundamentally addresses long-standing issues of manual watering inefficiency. Pressure-regulating valves and automatic controllers allow farmers to precisely control water flow and delivery timing, consistently supplying it to the root zone. As a result, leaves remain dry, the soil surface is undisturbed, and most importantly, water loss due to evaporation is virtually eliminated. In mushroom farms, where thousands of delicate caps lack roots to absorb water, drip irrigation becomes a tool for controlling life itself. Water is delivered in ultra-small doses, slowly absorbed just enough to maintain optimal mycelial moisture. Here, drip irrigation is more than just watering. It is precise microbial environment management. Welcome to the Jordan Valley, Earth's lowest point and simultaneously Israel's most unfavorable thermal basin. Here, where temperatures of 45 degrees Celsius can scorch nearly all life and the soil, encrusted with salt, glitters white as snow. Conditions long considered a death sentence for crops become an absolute advantage for date palms. The medjool date, often referred to as the black gold of the desert, is the star of this landscape. The extreme heat stimulates intense sugar accumulation, while the salinity of the soil naturally eradicates pests, allowing the dates to grow completely pure, without chemical intervention. However, producing export-quality dates, with near-perfect uniformity, requires significant technical intervention. Each mature date palm tree needs approximately 700 liters of water per day during the peak of summer heat. This enormous volume is drawn from the Jordan River and delivered through intelligent drip irrigation systems, directing every drop precisely to the root zone, sustaining life without increasing soil humidity, a critical factor in preventing fungal growth on the fruit. From August to October, when the harvest season begins, the date clusters ripen unevenly and are therefore meticulously monitored day by day. They are only harvested at the precise moment when sugar content reaches its peak. Harvesting is accomplished using specialized hydraulic lifting platforms, enabling workers to reach individual fruit clusters at heights of up to 20 meters. Each cluster is hand-cut, then slowly lowered using pulley systems to prevent impacts or surface damage. The moment the dates leave the canopy, the clock begins to tick. Within a 6-hour, golden window, they must arrive at processing facilities for controlled cooling and drying. This critical stage locks in the flesh's structure and the fruit's concentrated sweetness. Few realize that while medjool dates can be grown in many regions, only in Israel do they achieve the exceptional size, richness, and soft, toffee-like texture that the world relentlessly seeks. Once a luxurious gift to Roman emperors, today, medjool dates generate up to $350 million United States dollars annually, with an average yield of 120 kilograms per tree, double that of America's date capital, California. This is the most vivid testament to Israel's mastery in precisely controlling water, ripening, and sugar accumulation rhythms, something not yet achieved even in temperate climates. A naturally grown cherry tomato plant yields just 20 to 40 fruits, but in Israel, where nearly all national tomato exports are produced, a single plant can yield up to 400 tomatoes. The secret lies in a suspended growing system using sterile hydroponic substrates, which completely isolates the root zone from the nutrient-poor desert soil and eliminates the risk of infection by tomato brown rugose fruit virus, the most dangerous threat to tomatoes in hot and humid greenhouse conditions. This record productivity is maintained through precise drip irrigation, where every drop of water and nutrient is delivered directly to the roots, maximizing sugar accumulation and achieving high brick sweetness without overwatering or evaporative losses. And for clusters with crystalline shine and sustained flavor, Israel relies on a factor no machine can replace: bumblebee pollination using polymer hives. In sealed greenhouses, where honeybees often lose their orientation, bumblebees are the only effective vibrational pollinators, increasing fruit set frequency by 20% and creating uniformly plump, glossy, dark red tomato clusters. Approximately 100 days of intensive nutrient accumulation later, when a uniform red hue spreads throughout the fruit and the skin achieves a crystalline shine, the king of sweetness is ready for peak harvest. Harvesting is entirely by hand. One hand makes a clean cut with secateurs, while the other carefully supports the fruit to protect its delicate skin from the slightest scratch. This level of precision is mandatory to meet the demands of export markets. More than 80% of the produce is shipped to Europe and Russia, regions known for their exceptionally strict appearance and biosafety standards. With yields of up to 300 tons per hectare, Israel's greenhouse model has set a new global standard for productivity. Despite high infrastructure costs, superior quality control, and a record 40% reduction in water consumption have created Israel's unique competitive advantage on the global agricultural map. Moving beyond greenhouses, Israel is implementing artificial intelligence in open fields with autonomous apple-picking robots. As the global labor shortage intensifies, these robotic fleets are gradually replacing humans during harvest. Equipped with computer vision, the robots scan entire tree canopies, assess ripeness and size, and detect the slightest blemishes on apples while they are still on the tree. Once a fruit meets the standard, it is picked using vacuum grippers or soft clamps, ensuring zero surface damage. The true breakthrough lies in round-the-clock operation. These robots can work at night under specialized LED lighting, enabling rapid harvesting before unpredictable weather sets in. The result is a reduction in labor costs by up to 50%, while simultaneously improving fruit quality. This is how Israel is transforming traditional apple orchards into intelligent production lines, as precise and efficient as a high-tech manufacturing plant. Almost a quarter of China's landmass is comprised of deserts, where scorching winds and shifting sands impede crop survival. The Taklamakan Desert alone stretches for over 330,000 square kilometers and is so arid it is virtually devoid of life. However, instead of abandoning this harsh land, the Chinese have adopted an unexpected approach. They have begun to grow cotton. In China's desert regions, a suite of specialized technologies is employed to cultivate crops. Powerful tractors plow, level, and compact the loose sand, creating uniform rows. This reduces sand erosion from winds by up to 70% and helps retain soil moisture. Then, acres are covered with agricultural mulching film. This material reduces water evaporation by as much as 90% and preserves the warmth essential for seed germination. Through the combination of heavy machinery and advanced agro-textiles, the once shifting desert surface is transformed into a stable foundation for agriculture. After the sand is compacted and covered with mulch, seeds are planted in small openings. A drip irrigation system immediately delivers a precisely metered amount of water, ensuring reliable seed germination in the extreme dryness of the desert. Having endured months of punishing winds, extreme temperature fluctuations, and dust storms capable of destroying entire fields overnight, cotton plantations in the desert reach harvest season. With a now stabilized sandy soil, China moves to the crucial phase of technologically managed harvesting. Bright red cotton harvesters, from TA brand machines to the John Deere model, move in perfect formation, akin to a mechanized army, traversing thousands of hectares. Each machine processes 10 to 12 tons of cotton per hour, compressing it into dense bales within minutes. With global positioning systems, soil sensors, and automated control cabins, only 3 to 5 engineers are needed to monitor tens of square kilometers. Lacking the fertile lands that the United States possesses, China is compelled to create its advantage through technology, transforming deserts into large-scale industrial agricultural operations. It is, in fact, Nature's severity that has pushed the country to develop a generation of powerful, high-precision machines capable of transforming unworkable terrain into one of the world's largest cotton-producing centers. Leaving behind the white cotton fields of the harsh desert, we continue our journey to lush green rice paddies, where the power of machines and automation is transforming the face of agriculture. For centuries, rice transplanting has been one of the most labor-intensive tasks for Asian farmers. Bent for hours over flooded fields, manually planting each seedling, they could cover only a few hundred square meters per day. But today, everything has completely changed thanks to automatic rice transplanter technology. Modern rice transplanters, like the one you see, act as large-scale agricultural robots. A platform at the front holds dozens of seedling trays, and a system of mechanical manipulators at the rear continuously lifts, separates, and plants seedlings into the field at a constant speed. Each machine can cover between 1 and 2 hectares per hour, equivalent to the work of 40 to 50 traditional laborers. Real-time Kinematic Global Positioning System, RTKGPS technology, allows the machine to move in perfectly straight lines with an error of less than 2 centimeters, ensuring almost perfect spacing and density between each plant. Depth sensors automatically adjust the planting units so that seedlings are planted neither too deep nor too shallow. All this occurs while the operator simply sits in the cabin, monitoring parameters via a digital display. As the rice grows and enters the tillering stage, technology once again takes over the farmer's labor. Automatic spraying drones follow GPS routes, dispersing an ultra-fine mist over entire hectares in minutes, evenly and quickly protecting the rice with virtually no manual labor required. And as the green rice shoots grow taller, the fields turn golden. Harvest season arrives. Unlike wheat harvesters in the United States, which operate on dry, level, and firm fields, rice harvesters must operate in completely opposite conditions. Deep mud, soft soil, low traction, and a high risk of getting stuck. This is why their technology is specially designed. Wide tracks to distribute weight, automatic leveling systems to prevent tipping, and a cutting threshing mechanism that functions reliably even when water reaches the middle of the wheels. A modern rice harvester can process between 0.6 and 1.2 hectares per hour, replacing the labor of 20 to 30 workers. Inside, the threshing and ventilation system separates grain from straw in seconds, unloading the rice directly into bags or sealed containers to minimize moisture. With sensors monitoring soil moisture and settling, the machine automatically adjusts its speed to avoid damaging remaining stalks. While wheat harvesters in the United States move like steel trains across dry plains, rice harvesters in Asia resemble mud-crawling machines, finely tuned with high precision for every movement. As a country warming twice as fast as the global average, with recorded temperatures exceeding 50 degrees Celsius in Xinjiang and extreme rainfall forcing millions to evacuate annually, China is compelled to accelerate the development of greenhouse agriculture to ensure its food security. In modern greenhouse complexes, vegetable production operates like a clean food factory. Seeds are dispersed by vibrating machines with less than 1% error, incubated in perfectly climate-controlled chambers, and then moved to the main greenhouse. Here, high-pressure spray systems maintain stable humidity. LED lights are adjusted according to each growth stage to increase development by 20 to 30%, and robots continuously move trays to optimize lighting and airflow. All data, from leaf color to growth speed, is analyzed by artificial intelligence, which automatically adjusts environmental parameters hourly. Vegetables grow in such sterile conditions that pesticides are rarely needed, and contamination risks are virtually non-existent. When harvest time arrives, robots move the trays to a sealed processing zone, where produce is immediately washed, sorted, and packaged. The entire journey from seed to table remains within a fully controlled technological chain, reflecting the progress of Chinese agriculture in an era of harsh climate conditions. While this model ensures stable year-round production of safe food, its cost is 1.5 to 3 times higher than traditional farming, forcing older cultivation methods to evolve or risk being left behind. The hills of Shanxi and Anhui provinces have long been the cradle of China's finest tea varieties. However, traditional tea harvesting is fraught with risks. Clinging to slippery slopes, performing meticulous manual movements for hours, and a growing shortage of young labor present significant challenges. These challenges have spurred the emergence of tea-picking robots. These machines utilize high-resolution cameras combined with artificial intelligence to identify individual tea buds in fractions of a second, distinguishing young leaves from mature ones with an error rate of less than 5%. Their mechanical manipulators are equipped with micro-vibrating cutting blades that mimic the experienced pluck and pull of skilled harvesters, ensuring the shape and freshness of the tea buds are preserved. Each robot is capable of handling the workload of 20 to 30 human workers and can operate continuously, even in terrain that is difficult for people to access. As a result, traditional tea slopes are gradually transforming into high-tech, high-precision harvesting systems that are consistent, stable, and surprisingly efficient. Cabbage, known as a cold-season nutrient powerhouse, is one of China's key vegetable crops. And while many European fields still rely on manual labor, Chinese farms have taken an entirely different path. Harvesting is done by machines, as if working on an industrial production line. Cabbage harvesting is an extremely labor-intensive process. Each head must be manually cut, requiring thousands of repetitive bends and lifts of tens of kilograms every hour. This complexity has made cabbage harvesters an inevitable solution. These machines use high-speed hydraulic blades to cleanly slice each head in one motion, then lift it onto a moving conveyor, where an automated trimming system removes old outer leaves along the way. From the field to the collection hopper, the entire process runs seamlessly, without a single human touch during harvesting. Each machine is capable of harvesting between 8 and 12 tons of cabbage per hour, which is tens of times faster than manual labor. Ripeness sensors, anti-synchronization systems, and self-balancing capabilities allow the harvester to move smoothly across soft soil, transforming the entire field into an industrial harvesting line where speed, quality, and precision are maintained across every meter of land. When people think of blueberries, they typically recall Europe, but in China, this berry is entering a new era. Large-scale cultivation, high-quality wine production, and entirely mechanized harvesting. For years, blueberries were a harvesting nightmare for Chinese farmers. The small fruits were easily damaged, picked one by one, and required hundreds of man-hours per hectare. With increasing demand for processing, manual harvesting quickly became the biggest bottleneck. This has led to the introduction of specialized harvesting machines. Instead of relying on human hands, these machines use high-frequency vibrating rods to detach ripe berries from branches, tuned precisely to avoid damaging the plants. The falling berries are caught by soft receiving plates and then directly onto conveyors for pre-sorting. As a result of this mechanism, the berries remain almost completely undamaged, maintaining their quality for processing. A single combine can process tens of tons per day, replacing the work of an entire team of laborers. Equipped with sensors and navigation systems, the machines move precisely between rows, operating continuously like an outdoor production line. Consequently, vast blueberry plantations can be harvested faster, cleaner, and with greater uniformity, meeting standards for both fresh consumption and the production of premium blueberry wine. Now, let us step into Washington, the apple capital of the United States. Before you are giant shaking machines weighing up to 10 tons, built specifically for harvesting. There are two common types. The first uses hydraulic arms to grip and shake the tree, causing the apples to fall to the ground. Once the apples are dropped onto the ground, a windrower moves in, sweeping the apples from both sides of the tree row and collecting them into a neat line in the middle. Then, an apple harvester moves along the row. Its conveyor is positioned close to the ground with soft rubber fingers rotating like mechanical arms. It gently picks up each apple. From there, the fruit moves onto the main conveyor running through the machine, passing under air blowers that remove dry leaves and dirt from the surface before landing in a large bin or standard wooden pallets, ready for transport to the warehouse. This method is fast, capable of harvesting between 10 and 15 tons of apples per day, but the degree of damage is quite high. Therefore, it is mainly used for juice processing. For this reason, the demand for keeping apples intact for premium markets has led to the development of an improved shaking machine, equipped with a built-in catching frame. As the tree is shaken, apples fall onto the catching frame and are transferred directly into collection hoppers, keeping the fruit undamaged and suitable for fresh export. An apple tree typically takes 4 to 5 years to produce its first harvest, and this difference in harvesting technology reflects diverse market demands. Another type of machine has been developed to reduce apple damage. While not as widespread as the two previously mentioned, it is an over-the-row apple harvester. Its mechanism uses soft rotating brushes that run along the tree canopies, causing fruit to fall into collection trays before being transferred to a conveyor running through the machine. From there, the apples are moved into rear collection hoppers. This process allows the machine to move between tree rows and harvest continuously. What truly marks a new era in apple harvesting is the advent of intelligent robotic arms. Gone are the days when tens of workers had to climb ladders to pick each fruit by hand. Equipped with cameras powered by artificial intelligence, these robots can find ripe apples, precisely extend their grippers, and pick thousands of fruits per day. This is a game changer. The technology not only speeds up the harvest of millions of tons of apples, but also defines the economic value of an entire season. Carrots are typically harvested from September through November, when the root vegetables reach their maximum crispness and their skin radiates freshness. In major production regions, such as the Netherlands and Germany, farmers rely not on manual labor, but on specialized harvesters. For example, the Grimm Evo 280. The uniqueness of these machines lies in the fact that they not only pull carrots from the ground, but are also equipped with systems for shaking off dirt, trimming foliage, and sorting the harvest directly in the field. One such Grimm machine is capable of replacing the labor of hundreds of workers, operating around the clock while keeping the carrots clean and virtually undamaged. Above, thousands of bright orange root vegetables are visible, flowing along conveyor belts, creating an impressive spectacle of industrial-scale harvesting. Thanks to this technology, Europe supplies millions of tons of carrots to the market annually, ensuring both fresh consumption and industrial processing. But before this happens, in late summer, onion fields enter a harvesting phase distinct from most other crops. Instead of immediately being placed into crates, the onions are lifted by a special implement and carefully laid in long rows across the entire field. The onions are then left to mature naturally under the sun for 10 to 14 days, allowing the outer skins to dry and toughen, which significantly extends their storage life. After drying under the sun and wind, the onions are collected by a loading harvester. Rotating tines gently lift each dried onion onto a conveyor, where soft brushes and air blowers remove soil and loose skins. Onions of marketable quality fall into large crates on a parallel trailer, while lower quality onions are separated for processing. Deep plows traverse layers of soil that human hands could scarcely reach, demonstrating the brute force of modern agriculture. With massive mold boards digging 60 to 70 centimeters deep, they not only turn over the surface, but also break up the compacted hardpan beneath it, a layer that often restricts root growth. Each pass leaves long furrows of loosened, aerated soil that absorbs rainwater more effectively and reduces the risk of flooding. In Europe and the United States of America, deep plows are often used before sowing cereal or oilseed crops, preparing hundreds of hectares for the upcoming season. And if you were ever to run one in your backyard, forget about digging a foundation. It might just plow it for you. And here we see a shallow plow, a machine far more common than the deep plow. Unlike the massive implements designed to break up hardpan, the shallow plow operates at a depth of just 15 to 25 centimeters, focusing on loosening the topsoil where seeds will be sown. As it moves, the mold boards not only cultivate the soil, but also mix in crop residue, dry leaves, and organic matter, transforming them into a rich layer of humus. Simultaneously, this process helps suppress weeds and eliminate pests left over from the previous season. With its ability to create an ideal seedbed, the shallow plow has become an indispensable tool on most farms, especially before sowing rice, corn, or vegetable crops. Giant seed drills often stretch across fields with long booms spanning dozens of meters, resembling a massive frame laid upon the ground. Mounted on top is a hopper, capable of holding several tons of seeds, feeding them into small tubes that run along each boom. As the machine moves, each tube precisely deposits seeds in designated spots, followed by a mechanism that covers the soil and gently presses it down to ensure close contact. Models from brands such as John Deere or Vader Stud go even further, integrating GPS and sensors to maintain perfectly straight rows, control seeding density, and minimize seed wastage. This technology not only reduces costs for farmers, but also guarantees high and uniform germination rates. Few images capture the spirit of American agriculture as vividly as these perfect green circles carved into the desert. Traces left by center pivot irrigation systems. Their design is simple, yet ingenious. A pipeline hundreds of meters long, mounted on wheeled supports, rotates around a central hub, like the hand of a giant clock. As it moves, sprinklers evenly irrigate the field, creating such expansive circular patterns that they are visible from space. One center pivot system can cover 50 to 130 hectares from just one central well. The latest models even integrate soil moisture sensors, remote control via smartphones, and water usage optimization down to the square meter. Amazingly, this technology has transformed the arid lands of Nebraska and Arizona into fertile fields of corn, peanuts, and soybeans, helping to solidify America's position as an agricultural superpower. The J-Tech tree trimmer is a specialized machine designed for pruning in commercial orchards, from apple and orange groves to pine plantations. Its long hydraulic arm, equipped with high-speed saws, can extend over 6 meters, easily handling even thick branches. Moving along the rows, the machine neatly trims away excess branches, ensuring open and uniform canopies. The hydraulic system allows for flexible angle adjustment, adapting it to different tree types. Instead of dozens of workers climbing ladders with pruners and handsaws, one tree trimmer can prune hectares of orchards in a single day. In Oregon, pine trees are pruned with similar efficiency, but with a unique approach. Instead of manually trimming individual branches, a circular trimming head moves along the row, encompassing the canopy and uniformly shaping it, like a mold. Thus, each tree acquires a perfect conical form, ready for the Christmas season. Peanut harvesting typically occurs in 2 stages. The first is the digger shaker, whose underground mold boards slide just below the surface, cutting the roots and flipping the entire plant, as if to reveal the peanuts that were hidden underground. After several days of sun drying, the peanut harvester comes into play for the grand finale. Conveyors collect the plants, the nuts are separated from the vines, and air blowers clean off every last bit of soil. The densely packed peanuts fall into a hopper for storage, while the vines return to the field as green manure. Thanks to mechanization, these machines can process 5 to 6 tons of peanuts per hour, a pace unimaginable for manual labor. This unique 2-stage process makes peanut harvesting one of the most distinctive spectacles in agriculture. Sweet corn is a fast-growing crop. Once it reaches the milk stage, it must be harvested immediately. Delay for just 1 day, and half of its sweetness will be lost. In the fields, enormous combines roll like mobile assembly lines. Hydraulic arms grip the stalks, sharp blades make a clean cut, and the golden ears are lifted onto rotating rollers that shake off excess leaves before laying them neatly onto a conveyor belt. The process is completed in mere seconds, and within minutes, refrigerated trailers following the machines are filled with crisp, fresh corn. Nearly 340,000 acres of sweet corn are planted annually in the United States of America. However, more than 9/10 never reaches the market. Within 8 to 12 hours, the harvest is sent directly from the field to canning or freezing lines, preserving that initial burst of sweetness. Pistachios, a relative of the cashew, can live for over 100 years, but they require approximately 8 years before producing their first true harvest. From roughly August to September, the harvesting begins using pistachio harvesters, hydraulic vibrators that grip the trunk with rubber-lined arms and, within seconds, deliver powerful vibrations, causing thousands of ripe nuts to fall simultaneously. Beneath the trees, 2 giant catching sheets unfurl like umbrellas, capturing the falling nuts before folding inward to direct them onto a conveyor. From there, the pistachios are elevated into collection hoppers, while fans blow away leaves and dust, protecting the soft outer shell from mold. While Iran has long worn the crown as the world's leading producer, in the American market, nearly every pistachio consumed comes from California, a region that has transformed this nut into a billion-dollar industry. Did you know that a single sunflower head can contain between 1,000 and 2,500 seeds? Even more astonishingly, they are arranged in a spiral that follows the Fibonacci sequence, one of nature's most beautiful examples of the golden ratio. But this beauty fades when harvest season arrives. The fields no longer glow yellow but turn a dull brown with drooping heads awaiting collection. In rolls the sunflower harvester. Its sharp teeth guide the tall stalks into a cutting block. the dried heads enter a threshing cylinder, where thousands of seeds are separated in an instant. Leaves and husks are sent scattering on the wind. All the glossy black seeds flow along a conveyor, filling the hoppers behind. In moments, a withered field transforms into a river of living seeds, the beginning of their journey into cooking oil and countless sunflower-based products. Gliding between rows of hazelnuts, this intelligent harvester deploys dozens of high-speed rotating brushes, creating powerful air currents that are fed into a giant suction hose, engulfing a carpet of nuts, dry leaves, and loose soil from the ground. Unlike almonds or walnuts, which require vigorous shaking from tree shakers, ripe hazelnuts naturally drop simultaneously over a very short 2 to 3 week autumn period. However, this fleeting moment also presents their greatest vulnerability. Just one untimely rain can turn a golden harvest into a soggy, moldy disaster. The advent of this harvesting machine has completely solved the problem of racing against time, becoming a true savior for farmers in Turkey, Italy, and the United States, helping them secure millions of tons of hazelnuts annually. Once the entire mixture is drawn into the machine's body, massive fans and rotating drums create an artificial vortex. Dry leaves, dust, and light debris are blown away, while the heavy hazelnuts are gently deposited into a collection hopper in the rear. A single pass of this machine replaces hundreds of manual laborers, transforming grueling work into a compact, spectacular, and powerful display of mechanical precision. Combine harvesters, these towering giants embodying the speed and immense power of modern agriculture, ensure the collection of tens of millions of tons of barley annually across Europe. Standing over 4 meters tall and exceeding 10 meters in length, these machines are armed with razor-sharp blades and massive rotating drums that sweep across golden fields, cutting swaths of barley in just a few rapid passes. Inside, a compact yet relentless processing line comes alive. Powerful threshing drums spin at high speeds, separating grains from husks. Vibrating sieves continuously shake, removing straw and impurities, while powerful fans blow away chaff and dust. Following this perfectly synchronized movement, only the finest barley grains are transported to the grain tank, while the leftover straw is neatly distributed across the field, completing a flawless cycle with every turn of steel. With the help of these colossal steel reapers, harvesting millions of tons of barley in just a few short weeks becomes effortless. Even when sudden fires erupt under dry, scorching weather, they can still outrace nature, gathering the harvest, salvaging and preserving the golden season before the flames can spread. What happens if the irrigation canals, the life arteries of agriculture, become clogged with mud, debris, and weeds? In the worst-case scenario, the entire season's crop can be lost. Water stops flowing, fields crack and dry out, and crops wither under the sun. This is precisely why specialized canal dredging machines, like steel arms, were created to ensure the agricultural bloodstream remains open and flowing. Among the hundreds of designs existing today, the most common and effective are the hydraulically powered dredging machines mounted on tractors. With a flexible boom that can pivot 180 degrees, a rotating drum at its end scoops, mixes, and lifts silt from the canal bed, simultaneously trimming weeds along the banks. Some advanced models from Keops, the Netherlands, and Greentech from Denmark are even equipped with pressure sensors and auto-leveling systems, enabling precise operations in narrow trenches. In countries like the Netherlands and Germany, large-scale versions are also popular, fitted with giant grab buckets attached to hydraulic cranes. Dozens of curved steel teeth work like an enormous comb, scraping away silt and debris without damaging the canal walls, keeping water clean and flowing unimpeded. Thanks to mechanical power, just a few hours of operation from one of these machines can replace a full day's work for dozens of laborers, restoring clogged waterways and helping fields breathe again in rhythm with the growing season. In orchards where mangoes, avocados, or longans are grown across Europe and Latin America, the Greentech circular disc pruners are considered the ideal solution for small to medium-sized farms. Equipped with multiple high-speed rotating steel saw blades, these systems precisely trim each tier of the canopy, allowing light and air to circulate freely between branches. The result is balanced tree growth, uniform fruit ripening, and a significant reduction in pests, which is difficult to achieve with manual pruning. But for large-scale plantations in the United States, Brazil, or Australia, where each garden row extends for hundreds of meters, farmers opt for horizontal flail trimmers. Their wide cutting structure and blade rotation speeds exceeding 2,000 revolutions per minute allow the machine to process both sides and the top of the canopy in a single pass. Compared to disc models, which are geared towards precision, flail trimmers excel in speed, productivity, and covering large areas, making them the ideal choice for intensive agricultural regions where every minute of operation holds significant economic value.